Here we are in Chapter 5, Review 1, Exercises 29 through 34. Factor the following. We've been factoring for the whole chapter, and this is the culmination of it. We look here. Here's our little chart that will guide us through. We first try to find the greatest common factor. This one just has 7s and 5s, and this one just has 2s, 4s, and 8s, so there's no common factor at all. So we count 1, 2, 3, 4 terms, and so we are grouping. Chainsaw. We now have, what can we pull out of this guy? We can pull out a 2x squared, and we are left with 7x plus 8. What do we pull out of this next half? It looks like we can pull out a 5. And we're left with 7x plus 8. Yeah, that's good. So look, there are the 7x plus 8s right there to be pulled out of the 2x squared plus 5. That 2x squared and that 5 go right there. And we've pulled out that purple 7x plus 8. All right, that's good. Can either of these go down further? No, this is not a difference of squares, so that's the only kind of two-termer that can go down further. All right, number 30. Negative 4x squared plus 52x minus 168. Is there a common factor there? Oh, they're all even, so at least a 2. Can a 4 go into it? I think so. A 4 going into everything would leave an x squared minus 13x plus 42. Okay, so what is left? How many terms does it have? 1, 2, 3. So it's a 3-term with leading coefficient 1. So we're down here with, just one step. That's nice. I like those. We're here with a 42, and we got to find the factors that add to a negative 13. 1 and 42, 2 and 21, 3 and 14, or 6 and 7. And it looks like those guys, a negative 6 and a negative 7, do they really times to a positive 42 and add to a negative 13? They do. So there we have it. Oh, that negative 4 needs to stick out front, and that's what the answer would look like. Good. Number 31. 24m cubed minus 6m squared n minus 63mn squared. Looks like at least an m will come out of everything. Is there anything else? What about in 24, 6, and 63? Again, we're looking for the greatest common factor first. Looks like at least a 3 can come out of everything, 3m. So we're left with 8m squared minus 2mn minus 21n squared. There we are, n squared. Now what do we have? We have 1, 2, 3 terms. So 3 terms, leading coefficient is not equal to 1. That's an 8. And so we check, is that a perfect square? 8 and 21, not perfect square. So we're down here, the AC method. 8 times a negative 21 is negative 168. And we're going to find the factors of that add to a negative 2. So 1 and 168, 2 and 84. Does 3 go into that? Yeah, I think 3 goes into that. 56 times? Yeah, 56 times. Then 4 would certainly go into it, 42 times. 5, 6 will go into it 28 times. 7, does 7 go into it? Yeah, it looks like 24 times. Yeah, 8, yeah, we know that goes into it 21 times. 9, 10, 11, let me see, 12 will go into it 14 times. So with a 1 positive and 1 negative, do we know which it is? And that, yep, that's our magic set right there, 12 and a negative 14. So, this isn't one of these nice ones where we just put the numbers in. This is the AC method. These guys split B. So that means this is really 8m squared minus 14m plus 12m minus 21 n. Let's rewrite that so it looks a little bit nicer. So this b got split up. So it is negative 14mn plus 12mn minus 21n squared. Okay, so now we have 1, 2, 3, 4 terms, and this arrow says then you'll group. So let's do that grouping. So we take out of this side, we'll leave that 3m aside for a while and then put him back on the end answer. Here we take out a 2m and we're left with 4m minus 7n. Now on the second half, we can take out of a 12 and a 21, we can take a plus 3n, and we're left with 4m minus 7n. And look at that. Yay, it came out. 4m minus 7n pulled out of that 2m plus 3n, and that 3m just hangs out on the front, just kind of just falls down there. And there's our fully factored one. Wow, that was a toughie. Good deal. Okay, number 32. We're going to have 49x squared minus 121. Is there a common factor? This is 11 times 11. That's 7 times 7. No. So we count 1, 2 terms. It is a difference of 7 times 7, 11 times 11, squares. Difference of squares, which means it's one step. Square root of 49 is 7. Square root of x squared is x. And square root of 121 is 11. So it's 7x and 11 in both places. One's a plus and one's a minus to make those middle terms cancel all out. Oh, I like that one. All right, next, number 35. Ooh, this one looks terrible. Let's see what we got. Greatest common factor. This has 3's and 5's. That has 5's and 7's. That one doesn't have a 5 though, so 5's out. These guys have 3's. Those guys, I'm not seeing anything. Oh wait, there are some x's or y's that are common. Let me see. There's just one y that we can pull out front. How about x's? X to the fourth, x to the fourth, x cubed, x cubed. So we can have an x cubed and a y way out front, and we're left with 35xy plus 42. We pulled out an x cubed, so we have an x. Well, we pulled out the y, so it's gone. Plus 15y, because we pulled out the x cubed, and plus 18. We pulled out the x cubed y. Alrighty, so what's left has 1, 2, 3, 4 terms. So it looks like we can group. Let's try to group it. So out of the first half, we can pull a 7x, and we're left with 5y plus 6. Oops, let's get that different color going on there. Sorry about that. 5y plus 6. Now out of the second half, we can pull out a plus 3, and we're left with 5y plus 6. Make those parentheses a little better. And that allows us to pull that 5y plus 6 out, and we're left with the 5y plus 6 right there. And then the purple is 7x plus 3. And this guy just kind of floats down here. X cubed y out front. Oh, that looked really ugly, but this just step at a time, precise on each step, will get us to the answer. All right, the next one, number 34. Is there a common term? 81 has 9 and 9, which means it breaks down to 3's, and 4 just has 2's in it. So nope, nothing common there. How many terms? 3. Leading coefficient is not equal to 1. So let's check and see if it's a perfect square. 4 is 2 times 2, and 81 is 9 times 9. Oh, that means this might be 2x and a 9 squared. Oh, 9y squared. So what do we need to check? We need to check the middle term. This is minus. Oh, so that's minus. Is 2 times 9 doubled? See this 2ab? 2 times 9 doubled. Is that negative 36? It is. So that's our answer right there. We got it. Alrighty, those perfect squares are a little tricky, but that's the pattern.